He is having very vast experience in commissioning, maintenance, and operation of pollution control equipment. Today, Mr. Pancheshwar is going to share his practical experience in the area of pollution control in industry. So I welcome you again, sir, in this ATAL online 6 days faculty development program on clean energy and environment sustainability. Over to you, sir.
Yeah. Thanks. First of all, thanks Dr. Abhishek and whole BIT team for giving me opportunity to speak on this topic. This is really a matter of pride for me. And today I'm just going to share that something which, what are the practical problems which we are facing in our industries. So as you all know that pollution control is just let me share the screen for that my presentation first. Actually, I'm not using that Google Meet. We are generally well versed with that Teams. So let me share first.
Yes.
Entire screen. I have to select window. The three options are coming. Microsoft
Yes.
Window and
Entire screen, sir.
Entire screen.
Yes, sir.
Okay, then entire screen. I have to open the presentation. Oh my God.
Meanwhile, I request all the participants kindly switch on their camera so that we can take one photograph with Mr. Pancheshwar sir. Kindly switch off the mic. I request all the participants kindly switch off their mics. After the end of the session, you are requested to ask questions.
That presentation is visible or something?
No.
Entire screen share. Okay, then I have to select the share. Entire screen, then share. I have to select something.
Yes, sir.
Yes.
After that, you have to click on the screen that's you want to share.
Yeah.
And after that, click on share.
Okay, just wait. Just say your screen, and then my screen. Not coming. Share. Okay.
I request all the participants meanwhile kindly switch on their camera so that we can take one photograph.
It is coming right now?
Yes, it is
Yes,
coming.
sir. Yes, sir. Now it is
Coming.
coming.
Okay.
Yes.
Thanks. Okay, so let's start with our presentation. Yeah, Abhishek?
Yes,
Dr. Abhishek?
Yes.
Yeah, I'm
Yes.
starting right now. Okay,
Yes,
fine.
thank you.
Sorry for little delay because I'm just using that Google Meet first time because mostly we are dealing with Microsoft Teams and
No issue, sir. We are eagerly waiting for your lecture. Yes.
Yeah. So thanks. So as you know that industrial pollution is a very big subject, and today there is we have air pollution, water pollution, noise pollution, and soil contamination. So today I'm going to focus on the air pollution. So as you know that the most of the industries before right now in most of the industries, the most important thing is safety of the equipment, safety of the human is most important. Before starting any projects or something, we are investing so much on the how that people will remain safe during the whole life cycle of the industries. And the second most important thing what we are focusing before production or something is the pollution control equipments. And this is the most legal, and it is also a legal requirement as well as the requirement of the for the longevity of the plant also. So the industrial air pollution is of basically what is that pollution is there. The industrial process pollution is a various particulates and harmful gas get generated are called pollutants. So we are in the industries, basically we are generating fly ash, coal dust, iron ore, and harmful gases like SOx, NOx, and volatile organics. And we cannot release the same to the atmosphere up to certain limits, and we need to control this that particulates and that harmful gases to the desired level, and which is varying as per countries to countries. As you already know that most of the some industries are already closed down due to the high pollution. Like if you have heard about that, Vedanta Tuticorin plant was closed for almost 5 years for that not meeting the environment norms. And recently, we have also been fined by the Netherlands. uh, we have one plant in Tata Chorus also, where we have fined for 250 crores for not meeting the industrial norms. Here in India, we have a air pollution which we can release to the atmosphere is 30 mg per normal metric cube. But in Europe, that norms is very stringent, and it is more than almost 50 mg normal metric cube. And that's why most of the steel plants are going to are it is very difficult to operate in the European countries where the people are very much aware and they are more focused and more conscious on the health. So that's why the pollution control systems are very important. The effect of industrial pollution are environment degradation, health impacts, and it's contributing to the climate and economic cost due to cleanup and mitigations. Already I have explained what uh, things can happen, that health, it's affecting the health, it affects the health, and it's breathing problems we can face because of that. People who are working in the close vicinity with the dust and the air pollution, it's also affects the plant safety. If more emissions are there, then it will affect the visibility and some accidents or something can happen. And besides that, it's also reduce the life of the equipment. In the if the pollution control works, these equipments were not working properly, then the life of these equipments will be reduced. And then definitely it will also reduce the efficiency if the equipments were not working. So what are the benefits of the pollution control systems? It's definitely environment sustainability. If we wanted to live in the same atmosphere, if we wanted to give the same thing to the next generation, this is the main focus right now. Improved public health and the compliance with the regulatories, means legal compliance. It is must right now to meet our environment norms. And for that legal compliance, or most of the chimneys are being monitored by the government agency pollution control systems. If suddenly, if it is, we have in India, it's 50 mg per normal metric cube of dust we can release to the atmosphere. If it is going high, then our government team is continuously monitoring us, and it is online system. If it is going on the peaks, so we need to give an explanation and justification to the government bodies for that. So we are also, being a Tata Steel, we are also very stringent on that same thing. So for dust control, there are different methods to control the dust. The way that material producing, like the coal and iron ore, the process and operation of the generation, in the which process this process is generating, whether it is generating in the central plant, RMHs, or maybe in blast furnaces or coke oven or LD shops. So according to that process of generation, we are putting our equipments, we are selecting the equipments also. The physical location and operation of that, okay. And then other things are, what are the utilities available for the separation of the dust, whether proper electricity, compressed air, water, or the labors are also available for the such things. So that according to that, we are putting the pollution control equipments. So basically, air is considered to be polluted when it contains a certain substance in a concentration which is higher enough for duration and long enough to cause a harmful or undesirable effects on the human body. So this includes adverse impact on the human health, property, atmosphere, okay. And sometimes it is natural, and sometimes it is a man-made also. So for that pollution control, we have air pollution control, we have many equipment. Basically, it is so some equipments are cyclones, scrubbers, electrostatic precipitators, bag filters, and dust suppression systems, which I am going to explain you in the next some slides. So air pollution control technology are, I have already told that there are four, five types of that air pollution control equipment, and these are also divided into the constant efficiency type, and the second is constant emission type. And then constant efficiency type means if we are if the dust generation is higher side, then the if means that inlet is more, then the outlet is definitely is more. There is no point is that it's something, so we need to control some processes. But in some like bag filters is also constant efficiency type. Yeah, bag filter is a constant efficiency type. If the dust generation is even more, but the means out, if inlet is even more, but outlet will remain the as per the design parameters. So let's first read about that cyclones. So out of that, I have already told there are 4 or 5 equipments in that air pollution by which we are controlling the dust. It is a first is cyclone. In cyclones, generally that high velocity dust enter in this position, and then my cursor is visible.
Yes, sir, it's visible.
Sorry, yeah, thanks. Yeah, so then that dust is going in this direction, and then it is in high velocity. Then it is just impacting on the body of the that silo, and then it is just due to the higher that energy, that higher particles get impacted on that body, and it falls down. And the lower particles means that micron size get is coming out from that after the swivel motion is come down, goes outside. So that most some advantage of that cyclone is that it is um, very cost effective, and no moving parts is there, and heavier particles we can easily separate out. And the disadvantage is it is not designed for that microfines, means that size which is less than 1 or 2 microns. It is not designed for that, because it has to be released on that to the atmosphere. So first, generally where we are using it is a primary type of that cleaning system, and after that the gases which is generating, or maybe that dust laden gases which we are generating, it has to be passed through the bag filters and the ESPs for the secondary cleaning. Then we can release the dust to the atmosphere, which is should be the less than, as per norm, should be less than 50 mg per normal metric cube. It should be less than that. So it is generally that cyclone, and that the dust which we are generating from the cyclone, we are removing it from that RAB, and again it is we are recycling it to the our systems. Then we have similarly we have a, it is also a gravity separator is there, in which the high the dust is coming out with high velocity. Then that we are some suddenly that the pressure we are reducing it into converting into the low velocity. The pressure reduction is there, and then the heavier particles falls down, and the lower particles will go to the again for the bag filter and the dust catcher. Sorry, that bag filters and that ESPs. Then third system is that scrubbers. In that scrubbers, it is generally which we are using for sulfur dioxide and nitrous dioxide, means the for the removal of the gaseous impurities generally we are using, and it is generally utilization is in coke one, in which what is happening, we are putting gas from the top, gas is coming from the bottom, and sorry, and then dust in some places gas is coming from the bottom, and the water is we are spraying from the top. So the dust which we are that gases impurities are just like we have ammonia, high ammonia having very good affinity with the water, it comes down along with the water, and that dust impurities are also comes down, and then we are sending it to recycling it to other cleaning systems where we are settling it down, and then the dust will go to the biological oxidation plant and the that COD plant, the chemical oxidation plant, where we are removing the other chemicals, and then again that water is recycled. Then we have a Venturi scrubbers having a similar function, and the cyclone scrubbers. In this, I have already told the gas is coming from the top bottom, and that water we are spraying in the form of mist, and there is a packed wooden pieces, and that packed material is there. So gas has to pass through this, and then the heavier particles as well as that gas impurities are goes down, and then it is then moved to that whole thing is diverted to toward the chimney. So some advantages advantages are, it is generally for hot gases can be easily cooled. Sometimes in the system that hot gases are generated, which has to be cooled down before it has to be utilized in some other places, or maybe before it is sent to the some other source for utilization. Then corrosion gases can be recovered and neutralized. Disadvantages of this process is lot of wastewater is produced and poses a freezing problem of the cold countries. Maintenance cost is high when the corrosion and the material are corrected. Means if we are corrosive material are corrected, then these whole things are made up of generally a mesh plate or so so that corrosion is very fast. So we need to continuously remove these tanks also. So what are the advantages of the scrubbers are? Useful for collection of particulates and the gases. And then second is a general collection efficiency is 85 to 90%. Then required quite high amount of water for this. Can be problem if something that dust is get clogged in the packings, then it has to be again reopened and cleaned. So packing and clogging is always on the higher side. Cannot be used where the collected material is required for recycling. Means we are collecting, but recycling is it in the wet form. We need to dry it out again. And the second thing is this bag filters, which we have the third type of that pollution control equipment. It is a bag filter type. So generally in the industries, we are basically using the bag filters, and it is the most because it is a constant that dust type means its efficiency is very high. Whatever input material is there, but the output will remain for the in the lesser side. And generally it is designed for 10 mg, less than 10 mg per normal metric cube. So what is happening in the bag filters, I will explain you. So what is happening, the dust laden gases, okay, is entering in the systems. Then we have a bags like this. We have a bags like this, which enters the dust get stuck to that bag filters, and after that dust means some fan is connected, ID fan is connected. It is the dust laden gases enter, then it filtered, and then the filtered gas is going to the chimney. And what is happening in the next cycle, that compressed air of having high pressure around 5 kgs, 4 to 5 kgs pulse on this bag filter, and that dust laden gases falls, and again we are removing it from the RAB, and then again we are recycling it into the systems. So this is the basically a bag filters, which is the picture has been taken from the plant. So the bags is like this. It is like in a cylindrical shape and having a cage inside, like we have a skeleton. So it is advantage of this is high efficiency, and it's generally, and disadvantage is large area is required, high frequency of cleaning and maintenance is very on higher side. Operating temperature means we cannot operate it if, and this is generally made up of some fabrics having a temperature withstand of maybe 100 degrees Celsius, for the some, and maximum for the 200 or 250 degrees Celsius. If the gases impurities is having the temperature more than 200 or 200 degrees Celsius, then it is not we are not suggesting to use it for that gas. So I have already explained that the gas laden air enters from this side, it's filtered, and the clean air get out from the systems. And besides that, after that purging system is there, where it purges from these bags, and that the dust which is stuck into the bags, it falls down. And if the basic parameter which we are monitoring in the bag filter is the delta P. Means if the delta P means if the bags, the dust remain stuck to the bags and the purging is not happening, then in the next cycle, then the efficiency of collection dust will be reduced, and it will not able to suck the dust from the that conveying points. So we are monitoring the DP, and always we are maintaining the DP of the bag filters from 100 mm per water column to 200 of per water column. If that DP is increasing, means there is the cleaning process is not working properly, and if the DP is decreasing, means that the bags are torn out and needs for replacement. So this is the same thing which I have already explained. And generally, typical application of the bag filters are in power plants, fertilizer, steel mills, food processing. So it's widely used in every industries for reduction in pollution. So these are the bags, and this is the cage. This is the pulse jet systems which we are. I have already told it's a just there are some parts in that. So this is the screw conveyor. That if the dust is if generating dust, we need to convey it to the some other hopper. Yeah, pardon.
Uh, Sorry for the disturbance some part. Kindly continue and muting.
Yeah, yeah.
रुको ना यार तुम
क्यों
क्यों
तो
निर्भर
लेग
कर
बंद करा उसको नीचे में रखने में हाथ लगाया
Yes. Yeah, we'll continue. That then there is a gas inlet is box is there. This is the bags. This is the tubes, and this is the top axis which we are people are means worker or maybe laborers are going there, and for the place it is a place for that changing the bags. We are removing it from the top, and this is the solenoid valve. The purging is happening with the solenoid valve. So basically, it is useful for collection of the dry particulates, and we are not using for the wet systems, because if we are using the bags, then they get wet, and we are not able to use for same efficiency. So that water is very means dangerous for the bag filter systems. Then its general collection efficiency is more than 99.99% for the dry system. It's very high pressure loss as it's okay. Then result in recurring cost, means continuously we need to put money in that power as well as in purchasing of replacement of the bags, and it's required very high maintenance. Cannot be used where the moisture is present, and it cannot be used for the flammable items, because if something flammable things goes inside the bucket, then easily catches fire, and it is having a disastrous effect in the atmosphere. So already in some bag filters, we have faced in the problem of that high temperature that the bags got fired, and then so it is not recommended for the highly flammable substance. So generally that bags are made up of cotton, means that cotton, polypropylene, nylon, wools, and everyone is having some advantage as well as disadvantages, as well as the temperature range. Here it is also mentioned up to what temperature. If something like fiberglass is also having a 260-degree range, but those bags are very costly. So we need to. It is recommended that to have utilized bags as per our cost effective also. And some of the periodic maintenance which we are doing in the bag filters is basically we are monitoring to maintain its efficiency. We are monitoring the differential pressure, which we have already explained. The differential pressure is the pressure difference between clean air side and the leaden air side, the dust leaden air side. If the DP is on the higher side, means the cleaning process is not happening properly. If the DP is on the lower side, means the bags are got turned out and it has to be replaced. So we need to observe the exhaust stack. Then for the daily maintenance, what we are doing, then observe the control panel indicator, check the compressed air pressures. This we are doing, and the monthly checkup. As I already told, the back filters required quite high maintenance. So we are also monitoring the uh, that its fan should be in the running condition, drive belt should be in the running condition, check hoses and clamps, and then quarterly we are also doing some maintenance like check the gaskets, insects, and the baffle plates is inside the bag filters, so that we are checking. The fourth type, and which is very important for the high temperature, it's a electrostatic precipitator, generally ESPs. The electrostatic precipitator is a method of dust collection. In this, what is happening is that, just wait. Yeah. So in this, what is happening is this: there is in the bag filters there is a collecting plates, like this plate is there, and there is a emitting electrode in between. The emitting electrode, like we have in the back in that ESPs, what is happening is that that high voltage transformer is on the top. Then we have a wrapping system for that cleaning of the collecting plate and the emitting electrodes. So we have a collecting plates and the emitting electrodes. So what is happening in the collecting plate is that a dust laden air is enter in through the this distributor, and then it is in this system that that dust laden air is distributed properly, and we are just making this system in that negative, means negative field is generated inside the system, so whole dust get negative charge, and then in that collecting plate is a positive charge. So what is happening that the negative charge dust, which is once it entering into the atmosphere, it get collected towards the collecting plate. This is the collecting plate. So the dust get then dust get deposited on this collecting plate. In the next cycle, what is happening that the wrapping system, from that wrapping system, these wrappers are there for the collecting plates wrapping and the emitting electrodes wrapping. So this is hitting on these plates, and this the dust which got stuck into these plates got falls down. Okay, so this is basically a from the plant. This is a plant. Okay, then dust is entering through the ESP, then ESP, then it is going to goes to the atmosphere, means the dust laden gas enter into the ESPs and ESP, and then it is going to the fan, then it is going to the chimney. So this is the basically process. Okay, so this is generally used for the installation cost of this year, that ESP is very high, and the entire process of electro is generally it is divided into 3 or 4 hoppers also, and besides that it is used for very high corrosive and other dust also. So types of airborne particle separation equipment, so useful for the collection of the dry and the wet particles both. General collection efficiency is more than 99.9%, and it's very low pressure loss, very versatile in running, and low running cost. Its running cost is very high, and its maintenance cost is also in the lower side, because it's only its installation cost of ESP is very high. What is affecting the performance of the ESP is a good distribution system. So I have already told this is the distribution system. Once it is entering, so we have a holes in this distribution system, which is allow the gases to spread all around the ESPs. And then we have a then operation factors are also affecting the performance of the ESPs is a gas volume, like gas temperature, then dust entering the ESPs, then effectiveness of wrapping. Hopper evacuation system means the dust which is collected inside the ESPs has to be cleaned at regular interval, and the alignment of the electrodes, means emitting electrode and collecting electrodes alignment is also very important during these processes. Then gas volume is if the gas volume increase mainly due to malfunction of the operation, then definitely it's affect the performance sometimes, and there should not be any leakage, means it's the gas should be taken from the only processes. If the false air enter inside the system, then definitely it affect the performance of the ESPs. Then gas temperature results mainly due to malfunctioning of the operation and leakage and the poor maintenance. Then gas temperature. The gas temperature, if increasing, resulting mainly due to malfunction of the operation. If the high temperature inside the goes means maybe 200 or 250 or 300, then it is also deteriorating the affecting the performance of the plate. And also, if the plate also in some cases in our industries, we have seen that the collecting plate get deformed because of that high temperature, and then then the again then that system performance is affecting. So that the temperature we need to maintain. The SP is being designed for it is also designed for the depend. The SP is being designed for the given efficiency, and then the third thing is that the trapping system is one of the critical component of the SP. Means in the regular interval, the trapper should hit the collecting plate so that the dust which got stuck to the collecting plate should falls down. I've already told that. Just wait. I've already told the hopper evacuation system should be very strong. The dust which is generated in the process should be evacuated at the regular impact. Otherwise, it will touch the collecting plates and emitting electrode, and the short circuit will happen inside the ESPs. And for that, if because in there is hopper heater is also inside the ESPs hoppers, so that the dust which is getting collected should not get condensation, and that should not reduce its temperature. Otherwise, what will happen that it absorb moisture, and the whole it will jam the whole evacuation systems. Gas velocity is an important parameters. If the velocity is on the higher side, then definitely our collecting system will be not able to collect the dust which is going. So that the gas, we need to maintain the gas velocity as per the design. So generally in the velocity should be between 1 meter per second, and good practice is a good practice would be to keep that speed of the that gas generation is 0.2 to 0.9, and that we are controlling it through the that ID fan which is connected to the ESPs. Treatment time. Okay. Collecting electrode spacing means for the during that erection and commissioning, it is very important that the collecting electrode, the space between the collecting plates and emitting electrode is very important. Factors affecting, this is factors affecting the performance of the ESPs. I have already told the properties of the dust. Then the gas properties. Energization effectiveness means the performance of the transformer is there. Then effectiveness of the dust removal systems. So properties of the dust are also important. Like the properties dust that is collected in the precipitator has a very large impact on its performance. The fly ash, which is generating generally in the power plants, and the fuels and cement dust, cement cooler sponge, each have a different precipitation characteristics. So generally, sometimes that our ESPs is also having problems. So it is basically why it is happening is the check the under voltage tripping. Sometimes it is happening, which is due to the high ash disposal. Then the wrapping system is not working properly. Heating system means that is not working properly. Insulators for the cracks are there. So dust variable, then different type of then the last one is we have a dust separation systems. Generally, separation systems we are making, what we are doing, we are just, it's depend upon the types of the micron size which we are generating in the systems, like limestone fly ash and the coal dust and the cement dust. And what we are doing, we are making up that droplets of the water, like we are atomizing the water as well as with the help of the compressed air, and we are spraying in the that dust laden systems, or maybe in the conveyors line where it is discharged, material is being discharged from one system to another systems. There we are putting that dust separation system, and this dust are just getting, so this is the dust. Once we are spraying water on the dust, so this water get suppress the dust in this fashion. So this is our one of the conveyors and the transfer points, not just at the beginning transfer points, and we are spraying the water over this, and this helps in separation of the dust. For this, we need to also maintain the, for the system healthiness, we need to maintain the water hardness, and it should be as per the design parameters. And we are also have to maintain the compressed air systems properly for that. Sometimes we are also using some chemicals binders in the dust separation. If we are putting it inside the hoppers or something, so that the material which we are storing is not stucking, and it will, and they are not during transportation, they are also not producing much dust. So we are adding some chemicals in that also before transportations. So basically, cyclones are these are the 4 5 systems which we are having right now. And cyclones, the main example are cyclones are cheap to install, power consumption and is very less, and maintenance cost is normal. The filter is expensive to install, and well, its maintenance cost is very higher. An electrostatic precipitator, most expensive regarding installation, and its installation is very higher side, but maintenance cost is moderate. And the scrubber installation is cost is moderate, and the and maintenance cost is not high, and high rate of power consumption, and its scrubbers are also used for the wet systems. So these are some of the our plant data in what are the that CO2 emissions which we are monitoring. CO2 emission in each unit, like in DRI we have a CO2 emission is right now 1.79 was our plan, means actual, and plan was, and we have generated a 1.79, means the DRI plant is mostly a pollution controlling, it is there, and we need to per ton of production, it is the, as per our that industrial norm, it is 1.79. For central plant it is 0.32. For blast furnace it is 1.58. For we have 2 3 blast furnace, so it is a different data. For coke ovens it is for 0.2 of that CO2 generation per ton of production. And we are also analyzing in our plant why that CO2 emissions is higher in the some of the processes, and we are continuously making that system. We are continuously working on how our systems will work more effective. Then we have a water pollution control systems which we are not touching much. That effluent treatment plant is there. Then our CODs and BODs are there. Then sewage treatment plants is there. Then zero liquid discharge systems are there. Use of bioreactor and advanced filtration systems are there for the water pollution control systems. So we are organic as well as the wastewater from the coke oven plant contain mixture of hydrogen and cyanide, and before disposing it to the atmosphere, we need to reduce the hydrocarbons and the that cyanide, so that it will not affect the atmosphere. Then the wastewater which can be treated biological and chemical. When the biological treatment is applied, so there are 2 3 methods by which we can reduce the cyanide and other impurities from that. It's a biological and chemical treatment method is there. So this is just reading slide. So basically, we need to maintain the water qualities in each system. So if we are discharging it to the systems, we need to maintain the certain parameters also. The temperature of the water should be in the process should be less than 40 to 45 degrees Celsius. Suspended solids which we are discharging should be in the range of 25 to 35 milligram per liter. Then CODs, then cyanide should be less than 5 to 20. Otherwise, so this has to be uh, maintained before discharging. Then we have here in the solid waste segregation systems also, and then hazardous waste disposal systems also. Then the waste to energy means, so we have a lot of solid waste which we are generating, which is contaminating or polluting to the atmosphere. So we are also disposing it into the proper way. Like we cannot dispose the grease drums and other things into directly to the ground or something. It has to be disposed to the proper dealer where it can be properly incinerated or can be reutilized. Then we know that in another pollution is the noise pollution in the industries. So we are using many things. We are putting the then acoustic enclosures, then silencers are there in the different machines, and we are continuously monitoring the noise in from that our dB meters. It should be less than 85 dB, and the whatever going to the plant surrounding area, it should not cross 85 dB. And we are putting the sound arrestor and systems also all around our boundaries. And future trends is that we are also using that intelligent monitoring systems where our systems are connected to the one central unit, and all the pollution control equipment we are monitoring by our environment department. And besides that, we are also developing some eco-friendly technologies, and continuously we have our R&D departments who are continuously working how to reduce the pollution and circular economic. That these things we are doing continuously on the how to reduce pollution for that sustainability we have to do, and we are doing on that direction also. So that's all from me. And if you have any other questions, because the time limitation is there, it was told almost 1 hour 30 minutes, almost 1 hour 45 15 minutes I think. So if you have any question, you can ask.
Thank you, Mr. Yogi.
Yeah, so you can ask the questions regarding industries. If you have any doubt and something, you can ask.
Sudeep Kumar.
Yes,
Kumara?
sir.
Yes,
Sir,
please.
actually, you are talking about air pollution now.
Yes, sir.
So regarding this Delhi air pollution, have you installed any systems in Delhi to control, to mitigate the air pollution?
Means daily generation. Yes, in every plant we have a stake monitoring system. All the chimneys are being monitored centrally. So whatever that the emissions are happening from the air pollution, it is going through the chimney. So we are monitoring it through the chimney. If it is crossing our limit, that is in our industries, in our Tata Steel is 30 mg per normal metric cube. If it is going on the higher side, then why it is going on the higher side, I have shown in one slide. So we have to give the region to the government agencies also, whether there is process disturbance is there or any problem in the equipment. So every time it has to be maintained as per industrial norms. So we have very stringent system on that.
Okay, sir. Thank you very much.
Thank you.
Any other question from participant side? Any more question?
So the
Good
second,
evening.
yeah.
Good evening, sir.
Good evening.
Sir, you told that there is some use of chemicals. So can you give some examples that what chemical we are using?
Actually, we have if you go to the slide once again, okay, which will be shared with you. So we have some chemicals, means different suppliers are using different chemical agents. Actually, this is not our production. We are hiring this units, and they are giving it to the different names. So in my slides, you will find that some names are there. You can go through that, okay. And generally, this is not the means these chemicals they are mixing something. Okay, and they are also not sharing that data with us because there is a their patented products are there.
Okay, sir. Okay, thanks,
Yeah.
sir.
But they are giving their names and we are buying it by that name from that suppliers. In our
Okay,
case, we have a Nalco and they are giving these chemicals to us.
okay, sir. Thank you, sir.
One question from Salish Mantri. In
Yeah.
vaccine plants, there are major role of these contaminants. How to reduce it? How to reduce it?
Yeah, Dr. Abhishek, yes, I have not understood the question once again.
Uh,
In
in vac in vaccine plants, there are
vaccine,
major role of these contaminants. How to reduce it?
in vaccine plant means vaccine is a means wax plant something.
I am also not getting. Mr. Salish, are you able? Are you here?
Which plant is this?
Yes, sir, I'm here.
Yeah.
Sir, actually, I visited. I visit one of the vaccine production. Vaccine means just all types of.
Vaccine means that
Yes.
something which we are putting
So,
inside the body. Yeah.
I want to know how to reduce the major role is the human contaminants there. So how to minimize it because I'm just visit and I found there are so many problems.
So I have already told in the maybe in vaccine plant maybe some chemical they were using, and if it get maybe the life is got means it's expiry, then we need to dispose it in a proper way. So there should be some chemicals which we need to or maybe something if we are adding to the water, maybe biological treatment or COD or that chemical treatment plants might be there with them. Okay,
Yes, sir.
so
Yes.
that can be treated means aerobic and anaerobic something is there in which if you passes through that process, then the chemicals will be removed. Like we have also in our coke plants, a lot of cyanides are being generated, which is
Yes. Yes.
which is very dangerous if we will release to the ground or something to the atmosphere. If animal or any
Yes.
birds can drink, so they can also die. So it is our norms also to reduce that cyanide within our limit.
Yes. Yes. Thank you, sir.
Yeah, thanks.
Yes.
Sir, I want to ask one question, sir.
Yeah,
Yes,
sure.
sir. Please.
Good evening, sir.
Good
Sir,
evening.
as we are discussing, there are so many ways to clean our nature. So, and we are also seeing that there are chemicals present in those things. So it means we are doing one thing good on the expense of something bad. So, sir, is there any cleaner way or which is already present or used by the nature itself, which we can use and we can in a larger scale on a industrial purpose?
Yeah, definitely. If we goes to the 1800, we were using that maybe that 1800 or 1900. We are using coals to run the that trains. Okay, then we use diesel engines. Right now, it is electricity is coming. So suddenly, we are also just diverting ourselves into the renewable sources is also like air and that solar energies. So just trends are coming right now. Even the government are also giving subsidies if we are using more solar energies or something more windmills or that power. So they are also giving it. They are also means supporting such industries also. So definitely, even if I'm just giving the example of our UK based plant, we have procured the Tata Chorus, and the most of the plants were in the loss making because we were not able to meet the that um, environment norms there. So recently we have in Port Talbot, we have closed our steel plants because that industrial norms we were not able to meet, even investing huge amount of money. So we have just focusing on there on the green steel production means we are not putting that we are not producing steel through the blast furnace route. We will simply make a electric arc furnace where that scraps and other things will be melted, and it again then it can be utilized. So these are the green technology which we are putting right now. This is called green technology plants are also coming.
Still is coming in the market, yes.
Yes, and basically in our industry that coal and coke are producing more pollution in the steel plants. So we are also continuously working on the how to reduce the consumption of the coal and coke and it's to its minimum level.
Thank you. Thank you, sir.
Thanks.
Thank you. Any more questions from participant side? Yes, Ramaswamy. Mr. Ramaswamy.
Yeah.
Mr. Ramaswamy, do you want to ask any question? So
Yeah, Dr. Abhishek.
I think, so can I conclude the session? Okay. So Mr. Yogesh, really, I'm thankful, and we are thankful for such a nice presentation. And even government is also asking us to collaborate with industry. So definitely academia industry collaboration will give a bright future to the student. So
Yeah.
thank you very much for accepting our invitation and giving such an informative talk, real-time experience, whatever is happening in industry, all those things we have listened from you. So thank you again. Thank you.
One message from all of you.
Yes.
If you people are working on right now, you all are bright engineer, I know. If you can do something for the something or some, you can design some equipment for the pollution reduction, and you can do some R&D in that, and then your career will be very bright. Okay, because most of the industries are right now struggling and for how to meet the pollution control requirement, and this will come in India and other Asian countries also, which is very stringent right now in the Europe. So if it will comes, then definitely we need to rethink something where that if that industries can be run in a better way.
Yes.
Yeah.
Definitely, we will think in the direction. This direction. Thank you.
Thanks.
Dr. Murli.
Thank you, sir.
Thank you.
Yes.
Sir.